This is 6-3 polynomials. A monomial, mono meaning single, is a single term. It's either a number, a variable, or a product of a number and a variable, as seen in the column on the left. On the right-hand side up top here, it says not monomials. It's not a monomial if there's a negative exponent, if there's subtraction, or there's division. In order to find the degree of a monomial, we take the sum of the exponents of the variables. So in our example A, we have an exponent of 2 and an exponent of 4 on the variables. We have to have variables here. So since we have variables and the exponent is 2 and 4, we add those together and we get 6. So the degree of this monomial, is 6. Okay, in example B, the number 4 doesn't have a variable. Since it doesn't have a variable, it's 0. Because remember, it has to be the sum of the exponents of the variables according to that definition of degree of a monomial. And in example C, we have a variable. If the exponent's not shown, there's really a 1 there. So the degree of this monomial is 1. Pause the video and find the degree of these monomials, and then start up when you're ready for the answers. 1a is 3 because the k has an exponent of 2 and the m has an exponent of 1, and 2 plus 1 is 3. In 1b, the answer is 1 because the x has an exponent of 1. And in 1c, the exponent has a 3. So the answer here is 3.
Good job, students.
A polynomial is a monomial or a sum or difference of monomials. The degree of a polynomial is the degree of the term with the greatest degree. So what the heck does all that mean? Most people think of polynomials as a string of monomials added or subtracted together. So it could be like 2x squared, that's a monomial. But if you do a plus sign or minus sign in there, you've created a polynomial. So 2x squared plus, could be 4x plus 6, something like that. That's a polynomial. It's terms being connected by addition or subtraction. The degree of the polynomial is the degree of the term with the greatest degree. What that means is that you look at each term. So here's my first term, there's my second term, there's my third term. You find the degree of each of them. So this one is 2, this one's 1, and that's 0. And then from there, you find which one's the greatest. Since 2 is the greatest, the degree of this polynomial is 2. So let me erase some work here and we'll look at these examples. Example A, if I look at my two terms, my first one has a degree of 1. I do that every time. Okay, so the first one has a degree of 1, the second one has a degree of 5, and so the highest degree is 5. So that's the degree of this polynomial. Here's my next polynomial. I know it's a polynomial because it has a bunch of terms being added or subtracted together. And I'm going to look at the degree of each term. The first term is 3 because the 2 and the 1 with the y. In the second term, I have a 1 on the x and a 1 on the y. That adds to 2. And the last one doesn't have a variable, so it does not have a degree. And so my highest degree is 3. Okay, and in this bottom one, we have 4. In the middle, we have 2. And at second to last, we have 1. And the last one is 0 because it's a number. No variable, so it doesn't have a degree. And the highest is 4. So here's your answers to finding the degree of the polynomials. These can be confused very easily with a monomial. So remember, a monomial, like 3x to the second, y to the third, would have a degree of 5. But a polynomial, you have to find all of the degrees first and keep the greatest. Let's find the degree of these polynomials. Pause the video and try it on your own, and then play back when you're ready to hear the answers. Okay, so for the first example, 2a, we have a degree of 1 and a degree of 0 since there's no variable with the 6. And so the highest is 1, so that's our answer. And the next one we have, this first term is a degree of 5. Next term is a degree of 5 because I'm adding the 2 and 3. second to last term has a degree of 4, and the last one has a degree of 0. And so the highest degree here is 5. So that's the degree of the polynomial. In order to put a polynomial in standard form, you want to first find the degree of each term. So if I write out the degree of each term here, we've got the 20 is a degree of 1, the x to the third, negative 4x to the third has a degree of 3, the number 2 has a degree of 0, and the x squared has a degree of 2. And we want to put these in order from greatest to least. You're going to do the highest degree first. And so that's why this 3, the degree of 3, is written first here. The negative 4x third first. Next we have...
Good night, Mom.
The degree of 2, so I wrote the negative x squared. Then I have a degree of 1. That's 20x. And then last, the degree of 0, which is the 2, positive 2. So you just rearrange the terms so that the highest exponent, or highest degree really, it comes first. And the leading coefficient is the number that goes with the variable. So the leading one is just whatever's in front of the whole polynomial. So the negative 4 is the leading coefficient. So in the next example, the y to the third has a degree of 3, y to the fifth degree of 5, y has a degree of 1. So in order from greatest to least, we've got y to the fifth, y to the fifth, y to the third, and then 4y. And the leading coefficient is 1 because the number in front of y to the fifth right now is 1. The number with y is 1. Here's 2 examples. Try these. Pause the video, and when you're ready to play it back and get the answers, hit play. Example 3a. I'm looking for the highest degree first. Since x to the fifth has the highest degree, highest power, we're going to write that first. And then 9x to the third would be next. Since it's positive, I'm writing plus. 4x squared is negative, so I'm writing minus. And then the 16 is positive, so plus 16. Okay, let's separate that from 3b. The answer for 3b, we've got y to the 8th is the highest, so negative 3y to the 8th will go first. Next is the 18y to the 5th. Since that's positive, I'm writing plus 18y to the 5th. So for positive, we put plus, negative, we put minus. And then the last term here is plus 14y. The leading coefficient on each of these. So in example 3a, there's no number there, so the number really is 1. So the leading coefficient is 1. And in the second example, example 3b, the leading coefficient is negative 3. This is how we name polynomials. This is something that you just have to have memorized. So a degree of 0 is a constant. That's a number with no variable. So a number with no variable is a constant. If you just have a variable like x, for instance, that's linear. It makes sense because when we have y equals mx plus b, that's a linear equation because there's no higher degree, there's no exponent above 1. Degree of 2 is quadratic, degree of 3 is cubic, etc. You can finish reading these. And then the amount of terms. So the terms are the things separated by plus or minus. So if I write out like 3x squared plus 2x minus 3. Let's count how many terms we have. 1, 2, 3. 3 monomials basically in that polynomial. And so this would be considered a trinomial because there's 3 terms. So in order to classify the polynomial, we first need to know the amount of degrees. So the degree here, since this is a polynomial, there's 2 terms, the degree is 1 because that's the highest exponent. And the terms, there are 2. So there's 1 subtraction sign separating 2 terms, the 5x and the 6. That's where we get the 2 from. So here, degree of 2, because this is our highest exponent, this monomial right here, y squared, so its degree is 2, and then the amount of terms, so being separated by plus or minus, we've got 1, 2, 3 terms. Here, degree of 7, so that we're going to keep the highest because it's a polynomial. and then we're going to count how many terms. 1, 2, 3, 4. It's always one more than the amount of plus or minus signs. Since there's 1, 2, 3 operations here, there'd be one more, 4 terms. So to name these, we would go to our chart. A degree of 1 is linear, and 2 terms is binomial. So example A would be called a linear binomial. And the next one, degree of 2, is quadratic, and 3 terms is trinomial. So we would call this one a quadratic trinomial. And the last one we would call a 7th degree polynomial. 7th degree polynomial. Anything after 3 terms is called a polynomial. So in our first example, 4a, we have a degree of 3, which is cubic, and then we have 4 terms, so polynomial. For example, 4b, since it's 1 term, it's a monomial and the degree is 0, so it's a constant monomial. And the last one, we have an 8th degree trinomial since there's 3 terms.